Welcome to the Decode Podcast with Elias Malfovan, Daniel Stanfill, and Sean Kincaid.
Welcome to the Decode. This week we have Stan Rothschild with us. He's the president at Metallic Resources, Inc., hails from Cleveland, has a finance MBA, and is known as the solder guru. So, Stan, thank you for joining us. Do you want to give us a little background about how you found your way into our lovely industry?
Yes. So I am fortunate enough to be a second generation. My father founded the company back in 1979 with a partner. He had a double major in physics and chemistry and a minor in mathematics. So needless to say, he was
just
not
floating through school, just a real
kind of just
underachiever.
real underachiever.
Yeah.
So, and he had worked at various other competitors of ours in the industry. Actually, his first job in the industry was with, now it's Alpha McDermott. But back in the day, he started working with them, and they were experimenting with, taking byproducts or secondary metal, and then melting it down and blending it with virgin metal. And because you guys are in the business, you generate, for lack of a better term, waste. And one man's waste is another man's treasure, basically. So, but he pioneered our electrolytic refining process. One thing that makes Metallic Resources different than most companies is everything that we source comes from the aftermarket. So whether it be dross, paste scrap, plating anode, spent anodes, anode butts, that's our raw materials. So I joined the company in 1999. Back then I was actually proficient with computers, Windows 95, Windows 98, I'm, my knowledge of computers now has kind of been pushed to the side. So, but yeah, no. And then
They all got worse after XP anyway, so no big deal.
No, I totally agree. Those are some of the most stable platforms out there.
Yeah.
And then, I got my feet wet as the operations manager. If you're gonna understand the stuff, buy it and sell it, you got to be able to work the jobs. When you're out there, you're on the floor, you're doing it, you're understanding it, you're working the process. And I, for lack of a better term, I don't want to sound like an old curmudgeon, but we've refined our plating process so many times that the people doing the job nowadays, I look and I go, when I was doing this, we had to do it this way or we had to do it that way. I sound like the guy when I was in school. I walked uphill both ways, and but it's been a fun, enjoyable ride to see the evolution of the industry. And when I started, everything was tin lead. And then you throw the lead-free curve in there, and all of a sudden there's about 37 different lead-free alloys that everyone has to use and sell. And when you're out there buying dross, it presents.
See, we'll have producer Paul when this is airing. There's going to be a picture of dross on the screen because people who aren't familiar with it, it's going to blow people away that you are able to take that and turn anything usable from that at all. I mean, I can't believe that turns into something that can get repurposed and so I'm looking forward to this conversation to learn more about the whole process.
We take dross. We will take the driest, oldest, segregate the worst paste you can ever find. We can take paste from like 10 years ago that you found in a closet.
Really?
Oh yeah, no, yeah. I mean, that's raw material for us.
So Stan, for the listening only audience's benefit, can you kind of just give a rundown of a basic layman's definition of dross for anybody listening who may not be familiar with the term?
So the bulk of our dross comes from like the wave soldering process. All right. So for the layman, think of a multi-million-dollar pizza oven. All
I
right.
like it.
The boards are going through on the conveyor. And then at the end, there's a molten solder fountain. And the fountain goes like this and it goes up. And then as the boards pass over it, the metal holds the components onto the board. It binds them to the printed circuit board. But in doing that, it creates oxides. Okay. And by the sheer nature of the fountain, it pushes the oxides to the side of the pot. I mean, you can go on YouTube. There's a gajillion videos of, and then what happens is then a lot of the companies will scrape those oxides out. We provide buckets for free to customers, drums, the containers that they want to put the dross in. And then that dross, they put it off to the side, and that is, the base material, our what we like to call raw materials.
So it's really a sustainable practice. You're taking something that's discarded by all means and giving it new life.
Correct.
Yeah, so I don't know about how, I honestly don't even know who handles it in our facility and what happens with it when it goes elsewhere. I know things get recycled different ways, and we absolutely have to keep, if there's any paste on anything, that goes in its own container and gets taken somewhere. And if there's all the dross gets collected and put in a 55-gallon drum and taken somewhere, like it all gets recycled. I know that much, but so I don't know. I don't know whether it's just getting recycled to another facility like yours or what the deal is. I'll have to find out. But
I would say probably it's going to a facility like ours. If it's not, we have a phone call that we have to make after this.
Yeah, for sure.
Show.
Well, there's not many that do what you do, as far as I know, in the States, as far as especially for our specific industries of EMS, PCB manufacturing, where you can take that stuff and then reclaim it yourself at your facility. And that's what kind of was wild to me was I remember I was talking to one of your sales guys, Tim, and he was explaining to me the process a little bit about how you guys were plating out the impurities inside to make your pure tin. And that's crazy to me because, when we ran our circuit boards, right, through you have wastewater, and that wastewater is going to collect copper. And so we had these little resin beads that sat in these cylinders. And then it's a nasty process. You have to pump it full of caustic soda. Then you have to pump it full of sulfuric acid. And then you strip, all while this is happening, it's stripping into these huge, gigantic 500,000-gallon tanks. And then you end up with like this blue water, basically. All the copper.
With copper, you're going to get, with copper.
Yeah.
It turns everything blue.
It was all stuck to those beads, and now it's in the water system, right? And you can't just dump that down the drain.
No.
And to send that out would be a ridiculous amount of money. So what you do is you take these plates, and we called it electrowinning. And in the electrowinning process, you basically reverse the plating that you did in the circuit board. So you take you could do, some people use stainless 305, and then, or you could take a regular piece of circuit board material.
Yeah, and you could just shear it right off.
Yeah, and and then it would plate to it, and it was wild. Like after a week, that water was crystal clear blue. It was amazing.
Wow. No, it's wild what you're able to do. So basically, a lot of people, when they think about plating, you think about it like a surface finish. So you're thinking about a specific thickness and how you're finishing on the whatever you're plating. So what we're doing is we're trying to plate for like a weight, a density, but we're also looking to remove contaminants. And so basically with that in mind, what you have to think of with the dross, a lot of these contaminants would be higher antimony, higher copper with tin lead. tin lead starts out with no copper, but then you get to like J standard 0.4, you're above, you're above the J standard. The copper's starting to make the bath sluggish, things of that nature. And with the lead-free alloys, you got anything from bismuth, nickel, there's so many different lead-free alloys, and so a lot of what we do is testing. We do a lot of lab testing, a lot of threshold testing. So basically, we will make super impure stuff. We'll do it in a wholesale in the lab. And for those that don't know what a wholesale is, it's literally like we replicate a tiny little plating process, but it's like a desktop plating process.
You seriously, because I still have my old wholesale for PCB plating. I don't know what I'm doing with it anymore, but yeah.
We use it. And the little desktop rectifiers we have.
Yeah. And I don't know about yours,
like the 70s.
Mine doesn't look OSHA safe, right? Like mine is not. I'm sure yours is way better looking than mine did, but
but the thing is, so a lot of what we, when I joined the company, they had been doing tin lead for a while, so they had a lot of years with it, a lot of data. You didn't have as many contaminants coming in, and we look at certain metals as contaminants. You didn't have as many of those. So when lead-free came along, we had to do a lot of different testing. What was our threshold on nickel? What was our threshold on bismuth? What's our threshold on germanium? What's our threshold on cobalt? So there's all these new metals that were coming into the industry because you're going to lead free. You're starting to push those temperature limits, and you don't want to scorch components and things of that nature. So then they start out with, say, SAC 305. Then they go to maybe a lower silver alloy. They throw in something that might have bismuth in it, lowers the melting temperature a little bit. And so for a recycler like myself, this creates a myriad of different issues that I didn't have to deal with 20, 25 years ago when I started with the company.
What was the purpose of germanium? So for my hot air level bath, it was always dropping, and it was weird because the bath was like 600, 700 pounds of tin, right? So, but like they would be like, add like 3 grams of germanium, and you're like, and it's like literally like a couple rocks like this, right? It's right. A small, and in this huge
drop 700, in a bucket,
right? And you're like, and they're like, yeah, do that, and that'll be like, it's so powerful that just that little bit of amount. What do you know what it actually is?
What happens with a lot of the lead-free alloys? So the early ones, they look like hazy, and so what happens is tin lead, it's shiny, it looks good.
Yeah.
It's
like chrome.
It's just you look at it just looks beautiful. Mm-hmm. And then here comes lead-free, and it's like, it looks cloudy. It looks, for lack of a better term, dirty, and so what happens is you start to play with like the certain metals that act as grain refiners. And then what happens is they add that nice sheen to the solder. And unfortunately we live in a world where people equate aesthetics with quality.
Yeah.
So like they have to look at it. It has to look good. It has to pass the eye test before it hits any, x-rays or microscopes or anything of that nature. So, that lead-free, there's a lot of different little grain refiners in there that help the exterior appearance.
Yeah, now that I think about it too, it was only in the lead-free that I ever had to add that in.
Uh-huh.
So we have that in, I said chrome because that's what I think of, and both are selected on the lead side and the lead-free side. It's both super shiny, chromy looking because the lead-free side is SN100C on ours, and that has germanium in it too, actually. But speaking of the selective solders, so my understanding or my experience with running that machine would be that the longer I go without adding fresh new bars of solder, the harder it is for the I don't know. It's just like the solder gets more difficult. It's just like starts to get stringier. It gets clingy to the leads. It doesn't release well. And then I'll add a new bar. Boom. It all starts working great again.
So one of the things with lead free that you didn't have to deal with leaded was a lot of the alloys, if not all of them, start with a percentage of copper in.
Sure.
So, and then what happens is whether you're at 0.3, 0.5, 0.7, you're starting there. So then here you are, you're running the machine, you're running the machine, you're running the machine.
Some off of the leads and
correct. And then what happens is as the copper builds, you get that copper dissolution. And then what happens is I like to use the term the bath gets sluggish, especially with selective soldering. You have those tiny little nozzles.
Yep.
And then you get those tin copper intermetallics. And then as soon as that copper gets outside of that nozzle, it wants to start cooling and setting up right away, And then one of the things like a lot of the solder manufacturers do, us included, is we will sell a lead-free alloy without the copper in it to help bring the bath down naturally so that as you're adding in the bar, the copper's not building as rapidly. With tin lead in your selective, it was pretty simple. You had your tin lead intermetallics, your tin copper intermetallics. So what you do is you turn the temperature down a little bit in the bath. You let it sit for 8 hours, 12 hours.
Rises to the top.
Yes.
Every morning, buddy. Every morning of higher level.
Those tin copper bad boys rise to the top. You skim them off, and then what happens is, if the tin drops a little bit, we could sell you a little tin additive. You drop it in, boom, you're going. Lead free, you can't do that.
So, and you're talking about the workability of it and stuff, and that's what I notice. And my inspector will tell me that too. Like she can tell if it's been a long time, if it's not a long time, but when it's approaching the time for it to get cleaned again, like as soon as it's approaching that time, she can always tell. So maybe we need to shorten that cycle so it never reaches a point where she's like, is it almost time? But my question is, how do you actually recycle that and get it back to good again if it's already been used that many times? Like, how do you give new life to such a
and so primarily too in the lead free, it's and our big thing is, and this is my PSA on cleanliness. So obviously you guys do maintenance on the pot and all that stuff, but you would be shocked at the amount of people that aren't doing a regular sampling process. So, and when I mean sampling, they'll take a little scoop, send it to
let it cool, send a little puck. Yeah.
And so higher volume shops, we recommend them doing it more often. Lower volume shops, we recommend you doing it, per how you use the machines. But just knowing what's the composition of what's in there is very helpful, because we have customers that we sell a lead-free bar with copper, and then we have customers that we sell lead-free bar without copper as well. So as their copper starts to rise, before it hits that sluggish threshold, they'll start adding in the non-copper replacement bar, and then it drives it down, and it makes the solder, for lack of a better term, more usable, flow better. You're not going to have as many defects. I mean, let's face it, selective came about because everything's getting smaller. That you're getting like finer pitch. Everything's just shrinking and becoming more complex and
complex assemblies for sure. Mixed technologies.
Oh, absolutely. I mean,
so speaking of mixed technologies, if I can just switch gears a little bit here, because all this through-hole technology talk is offensive to a stencil guy like me. So let's talk surface mount. Let's talk surfaces. So you mentioned the transition to lead-free solder. In regard specifically to solder paste, outside of the change to lead-free, in the last 25 years you've been doing this, what have been the most significant changes to solder paste technology, and what are some of the challenges that have arisen from that?
So I think one of the most significant changes is the industry move in the flux type. Other than lead free, so like when I started, we had a lot of RA fluxes, a lot of rosin activated, really aggressive. They functioned really well. And some of them were nasty, And then there was the move to water soluble. There are a lot of people that still use water soluble, water wash,
Those
whatever
can be
term you like to use.
aggressive too.
And those, yeah, it's very aggressive. And then you got to clean them. We live in a world where cost now is a big factor for everything. So you add that extra step of cleaning, then there's the move now to no clean. And no clean for some reason has seemed to become the dominant industry leader when it comes to paste fluxes. Mm-hmm. And you can run it once, it solders, looks good, it passes all your inspections. There's no other work you have to do after it exits the reflow oven, and then you're moving on to the next step. As far as I would say, another challenge.
You'll have to hammer that out with Mike Conrad.
Yeah, I was thinking about that. He's a cleaning guy, so he's going to be like
somewhere shaking his fist right now. No clean doesn't mean no clean.
Yeah. No. Here, for the stencil guy, I have horror stories on stencils. I could go hours on just stencils. So, I'm here. I hear a little segue. So a little side. I'm in a customer once, right? It's cartridges, automatic dispense, squeegee, all that stuff. They go, we're getting all this excess solder on the board. And we go down on the customer and all that stuff. We walk in there, we look at the stencil, it's got all these gashes in it. Oh. And I'm never gonna tell a customer like, hey,
time to buy a new stencil.
But as it's running over the stencil, every place that there's like an impression, the solder's just sitting in there.
Yeah.
And then so what am I gonna tell the company? Hey, you better take better care. But I've been to some shops where their stencils are the thinnest you've ever seen, and they are immaculate after the 1,000th use. I've been to some places where they just beat these things like you have never seen before. So everybody's different. No, go.
I was going to say we get some returns after they've been used for a long time, and I think the worst we've seen was like there was a stencil that was like 15 years old, and they're like, I don't know, it's not working well anymore. It used to work fine, and this thing just looked like it had been to Fallujah or something. It was just terrible.
Yeah, you hold it up and you go, see this hole over here? That's not supposed to be there.
Yeah.
No, that's
have you noticed a trend in paste type towards the smaller particle size direction?
Sure. There's been a type 4 it seems to have become, I got my phone, right? To my 4th grade math teacher that said I would never have a calculator in my pocket. She was way wrong. I mean, you look at that board right there, and everything that goes on that board and what it has to accomplish. I mean, the smaller chips, components. I mean, your pitches just keep. We have some customers that are at type 5 already. We seem to have more people using type 4 and asking about type 5, and mainly it's when they're getting to those smaller, more complex board designs.
Does the type of paste that it was matter in your reclaiming process, or does it all come out the same?
It all comes out the same. So what happens is like we have an afterburner for our paste that we use to recycle the paste. It captures all that hazardous air pollutants, all that stuff. And then when it comes out, it's a just nice big giant block of metal when we get done casting it out. And then the paste, much like the dross, much like the anodes and everything, it all goes through our electrolytic refining system.
That's what I never understood. In fact, one of your competitors, I used to send the dross that had like the oil on it from the hotter level. And he was like, dude, if you send me another bucket of this, like, I'm not taking your scrap anymore. And I just always pictured like too, like I think of like a refinery, like what I see in like Terminator 2, right? Where like there was like melting and then there's different chambers that the liquid flows into. Is there a way like you separate the liquidous metals by weight, or how does that work?
Now, so what happens is we basically separate everything by leaded and lead free. That's how we do it. And because of the way our refining system is set up, we have tolerances for lead free that allow so much lead in them. And so we have a tin lead plating system, a whole area where all that goes. And then we have our lead free plating.
So
You know,
the liquid molten image in my head is I need to replace it with like a plating bath.
Yeah. So okay. So we have
real quick. Let me put this in there too, because occasionally, like once a year, it'd be good for your tin bath. You would take we call them dummy panels, and we'd line up all the way across, and you'd plate at a really 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 low amperage for like 8 hours, and that at that low amperage for some reason draws the impurities out into that panel, and then you scrap the panels, from there. But is it something like that where you at a certain amperage of plating, or I just don't understand how it separates inside the liquid?
So imagine, it's a process. So imagine like baking a cake. All right. You have your ingredients, you have your eggs, your flour, sugar, and all that. Our ingredients are the contaminated metal. So like drosses and stuff like that in the paste, we get it to a metal block form. So all the oxides and everything, we have a rotary furnace that we use. We have low temp melting pots. We have an afterburner. We have different high temp smelting furnaces. So depending on what it is, it depends on what area it goes to. And then what happens is everything is converted to metal. But I mean, we're sampling all the way through the process. When it's received, we're sampling it. When it goes through its first melt, we're sampling it. When we combine it with other lots, we're sampling it. That way we know what we're dealing with all the way through the process.
What if I threw an aluminum circuit board in there?
Well, fine. 10,000, yeah, it's a little bit of a problem. It's all scope and scale, There's some solder alloys out there that are 9% zinc. Like, and zinc's a little bit of an issue for us, okay? But it's all scope. If you tell me, hey, I have 91% tin, 9% zinc, I'm like, oh, how much weight you got? 300 pounds. Well, I can take that in because it's gonna be blended with other things, and virtually the zinc will disappear before it even gets to the blading process. But now if you tell me, hey, I have 2 truckloads of it, I have to, I have a little more math that I have to do to make things work. So a lot of times what we do is we have predetermined thresholds, and we actually have what we call we have a title at our company, he's a materials manager. And all he's doing is looking at everything we have on hand. He has all the assays, and he's making all our composites for our anodes. When I mean composite, we're blending different pieces of metal and everything. And he's been with us a long time. And so we can blend a lot of different things together and get a certain result before it even goes through our plating system, just based on weights and how we can take things down below certain thresholds then.
Which, by the way, your tin anodes, I'm trying really hard not to plug you guys, but your tin anodes, man, were the shiniest anodes I'd ever seen in my entire life.
Well, you know what that, I can tell you what that is. So the electrolytic plating process, okay? Tin has like a really super, it does oxidize, but it has a really super low oxidation rate. But when you with the electrolytic tin, you have a lot less micro oxides encapsulated in the metal. And so when it comes out of the process, it looks brighter, shinier, and those micro oxides, they don't develop like they would out of some of the other stuff.
Yeah, I mean, I remember seeing a picture of it, and I was like, "This is just, it's too."
Think we like polish it.
Yeah, because usually what you have to do is you get the bars in, right, and then you got to screw your hook onto it, and then I'm spending at least 10 to 15 minutes scrubbing it with sulfuric acid and a Scotch-Brite, right? Like just kind of going over and over and over. Rinse, DI water, scrub. But like with yours, I mean, I still did it because out of habit, but and it was like the results after your first or second scrub were already there almost from your first one. It was like it was I'll try to find the picture because I know I have it somewhere on my phone. That
yeah,
slab.
it'd be good to put up on the screen here.
No, yeah, no, and a lot of things too is we can control the purity of the process because a lot of the cathodes that the metal's being plated on is our pure metal already. So those are all made in house. And so we know that like the stuff that's coming over. See, a lot of people when they think of plating, they think like it comes off the anode and it goes right onto the cathode. It's actually not the case. What happens is it comes off the anode and they're metal ions, okay? And they're in the bath. And then when the bath gets saturated, then the ions start to cling to the cathode. And so that's where you're getting that purity level at is that. And then all the other impurities are dropping to the bottom of the tank.
Yeah, it's I think you're probably like the fourth or fifth person in the world I've talked to that understands that process. Because I think I've mentioned it here a couple of times too about, there's these copper ions in the bath, right? You see these anode slabs, but once they bond with the PCB plating process, it's like 3 different chemicals: brightener, leveler, and carrier. And when those 3 mix with the sulfuric acid with the water inside the copper acid solution bonds together, that's what actually forms to the actual PCB itself. Yeah. But it's rare. I've never never experienced anybody outside the circuit board world the circuit board plating world that deals with that as well, that understood that process.
We're constantly doing stuff. We actually have a plating line. Do you guys know pewter? So pewter is like, that like old school
Yeah.
the chalices and the plates and all that stuff. So that stuff's high tin, lead, silver. Back in the day, they had lead plates. People wonder why people died at an early age.
Right.
You're drinking tea out of a glass with lead in it.
Yeah.
But yeah, so you get different babbits from the industrial a lot of industrial applications. You'll get they call them like radiator drips and stuff like that from a lot of like industrial type processes. And what happens is we actually have a plating system specifically designed for that stuff. I call it like the less sexier, like the electronic dross is like the good stuff. That's
the good stuff.
Yeah, it's the good stuff.
Okay.
That stuff. There's so many different variations of that stuff. I mean, if you go on Wikipedia and you look up Babbitt, they got 1,000 different like levels of tin and so like that stuff is always moving. It's a fluid movement where, tin lead, it's 6337, it's 6040. Every now and then you'll get a 6236-2 in there. I mean, there's not much to it. It's pretty basic. But when you're looking at a lot of that industrial stuff, the ranges they're all over the place. So we have a whole separate system set up just for that material.
So when we're firing up different types of paste and dielectric and conductive paste on thick film, we're going to like 865 degrees Celsius, I think. What's the hottest temperature your processes are running?
we don't have to get that hot. I would say, you're looking at like 900,000 Celsius. It's not, I mean, when you're melting metal compared to like steel, people look at steel and they're like, oh, 4,500 degrees. Oh my God, it's so hot. Lead has a low melting point. For lack of a better term, tin has a low melting point. I mean, even compared to aluminum, the melting points of this stuff are so much lower.
Sure. Well, Stan, I know all of us are super grateful for your time, and this has actually been like hugely informative to myself and hopefully the rest of the audience and everything. Before we go, do you want to give one more kind of overview of what Metallic does and what you guys offer?
Sure. So much like I've been talking about, our marketing says we're the solder dross experts, so we need that dross. I mean, we like solder dross, we like paste, spent anodes, that's our raw material. So we're always out there actively buying that stuff. And what we're doing is we're taking those byproducts, we're taking those goods, and we are recycling them back to a high purity tin, a high purity tin lead, and we're selling it back to the market. I know there's a big push for sustainability and, zero carbon and things of that nature. And our company, we like to say we're on the forefront of that push because we're not sourcing metal out of mines. We don't buy any virgin material. And, we continue to try to innovate. Actually, it's a funny thing. Sean, I got to talk to you after this. We're developing a new paste flux, and I need some people that I want that I can send our guys out to test it in the field. So,
David's still around?
David's still around. Yeah,
David is
come out.
Talk about a genius. That guy.
I love that guy.
That guy is next
I
level.
absolutely love that guy.
He reminds me of like the guy you were talking about earlier with the PhD in chemistry and all that stuff.
He has 2 PhDs.
Yeah,
David has 2 PhDs. He does.
I mean, you talk to this guy and like you just tell him like, yeah, just the flux, like the flux we were using was nice and sticky, right? Like that we wanted that for the hotter level, but we don't want that flux nice and sticky for the selective solder. So you just change the formula for this, and this, and he's like, yeah, this, and boom, it's there. And he just
I mean, it's a pleasure working with him. Dude, guy's got 40 years experience in the industry. Like it's a pleasure working with him. But he still loves doing it too, and he loves innovating and coming up with new things. Like we had an issue once at a customer. They bought a new machine. They went from a 5-zone machine to a 7-zone machine, and the profile they had wasn't working. We're like, oh, we'll come down, we'll run some panels, this and that. I'm talking to the head engineer and the salesman. He's already off with the operators. They got the profile up. He's like, we fixed it. We weren't even there like 10 minutes. Yeah. And I'm like, get out of here. They put the board through, worked just fine.
Yeah. Super nice guy.
Oh, I love him. And so I actually want those guys to come out, run some field studies with you. And by the way, your videos, this guy has a career. He has a career in film.
That's just what he needed to hear. Because honestly,
we'll edit this out.
Sean is. He's been really concerned about his impressions. The poor guy's been struggling, so it's good for him.
We're just giving him a hard time. He's got a knack for it, and well, this has been awesome, Stan. I know
I appreciate you guys letting me come on.
I've learned more about solder and reclaiming, and I didn't even realize that you could take stuff that was basically discarded and turn it back into new product. So that's awesome, and I think maybe there's going to be a little facility visit in our future because I need to connect the dots.
No, absolutely. No, we welcome you guys, just not in February when we have 10 feet of snow.
Yeah.
No. Come when the weather's.
That sounds a lot better.
I don't do snow, but yeah, get in touch with us and we'll bring Sean and his 360 camera and maybe shoot some footage there. But
I already told him in like December, I was like, dude, it's 40 degrees. I'm coming out that way. And we had one day and then he was out of town. And I haven't had a day since that it's been above 40 since then. So it's like,
I know, I came back and it's been like a deep freeze out there.
Yeah. Well, thank you so much, everybody, for tuning in.
Thank you guys.
This week's episode of the Decode. And if you enjoyed what you heard here, please go through our library and catch our previous episodes. And we'll catch you next time. Thanks again, Stan.
Thanks, Stan.
Thank you.
Time.